my name's Ken Dooley from Granlund in Helsinki. I'm a technology director in our innovation and development side. And today I'm going to combine a few topics like kind of user experience, smart building technologies, and digital twins. So trying to show how they can solve kind of a wide number of problems. Let's start with smart buildings and user experience. So we've been working on this quite a lot over the last couple of years. One kind of really clear thing that we've had to really understand ourselves is really where kind of smart building technologies and user experience technologies, kind of where the line is. So for us, smart is more related to kind of efficiency and performance monitoring, like, space use or noise or humidity or kind of leak detection. And user experience is more to do with kind of making people's lives easier. So, if you want me to give feedback, it's one click, helping people to save them time by finding a room or a car parking space or a colleague. And even something as practical as if there's a restaurant in office buildings like we have in Helsinki, so I can time my trip to the restaurant for lunch, so there's not a big queue, and kind of seeing the lunch queue from my desk. So these are some of the kind of divisions between, let's say, smart building and kind of user experience. And I'll show some examples of projects where we've been implementing user experience solutions. Another thing about the user experience is it kind of talks about friction-free. This is a word from Siemens. They don't talk about user experience increasing productivity. They kind of talk about it reducing or taking away productivity killers. So, taking away all the small annoying things in a person's day, very much on office buildings and university campuses and these kind of things we've been working on. One of the drivers behind this real focus on user experience, some of the first times we saw this discussed was in this World Green Building Council document from a few years ago, really outlining that, staff costs for knowledge workers is a huge percentage of costs. So it's much higher than rent and energy sometimes. So solutions that can help make the staff happier or more productive then become really interesting. One of our big cases for the last couple of years came from last year. It's Nokia's campus in Espoo. They had in the kind of main capital area in Finland. They had 3,000 staff, and they really wanted to increase kind of employee experience, to increase collaboration and reduce space. And although collaboration was a really big driver for a lot of our projects like this over the last couple of years, and we're a little uncertain about what that means now after COVID-19, it's still really important where we have so much digital disruption or when we have so much new technologies to really have people kind of bump into each other and to collaborate. Collaboration doesn't really happen in forced scenarios like meeting rooms or workshops. A lot of important conversations happen in lunch restaurants, in corridors, in car parks where you bump into someone. And they also focused on reducing their space as well. So the main kind of three things we were kind of really focusing on in the big Nokia campus project was to really show where the free spaces were, to help people really rapidly and easily book the free spaces, not having to click 10 buttons in Microsoft Outlook, for example, and to really show them and help them find the route to different spaces if they'd never been to an office meeting room space before, for example. And it also showed kind of where the free desks were. This is an example of showing the meeting rooms that are available, the meeting rooms that are booked, and the desks that are available and the desks that are booked. And actually, here's an example of the same solution on a smartphone app as well. And the location here was coming from the phones and the laptops, and we put a lot of iBeacons in the building, and the iBeacons connected to the app on the laptops and phones, and really kind of positioned people and really worked out where they were. So it was a really efficient way to measure location of people. It was much more efficient than kind of putting people counting cameras or putting, let's say, desk sensors everywhere. The information is anonymous, so you can't see who is sitting where, and you can't see who sat where yesterday. But if people want to share their location with you or share their location with a wider kind of company, then you can search for them and find them if they share their location. If not, they're anonymous and we just see that the room is booked or the desk is booked. Another example we did on this campus as well from a user experience point of view really was kind of giving communication for the restaurants. So being able to see the menu on an app, being able to pay for it from your phone and then turn up with a QR code, which really speeds up the payments. And then also showing with this red, green and yellow icon here, the busyness of the different kind of food counters, depending on what cuisine people are kind of interested in. So on this day, it was kind of busy. For example, you can see in the bottom, it was busy in the pizza queue. I think in summary of what we've learned about user experience lately, it isn't about smart building technologies that make the indoor conditions great. It isn't about ventilation or heating or clean water or good lighting. People tend in certain countries, and definitely in Finland, to take those indoor conditions issues quite for granted. So the kind of solutions that have been growing of interest over the last couple of years are things that save people time, things that help you to be healthier or keep you safer or help you to be more environmentally sustainable, maybe services that provide more choice, and definitely and engineering houses like Granlund need to remember this. People want the solutions to be super easy to use. They want you to open an app for the first time and for it to be intuitive and for them not to have to learn for a long time, how does this work in between? And I think there's a lot of inspiration coming from the kind of platform economy apps here, like Uber for taxis, or we have Volt for food delivery here in Finland, or even some of the parking apps where you don't have to put money in the parking meter anymore. You can just download an app and then you kind of turn an icon to say, okay, I'm going to park in this space for 2 hours. Super intuitive, super easy to use, and really kind of focused on saving people time and making things easy. So one of the things we've been looking at are these smart office apps. I'm a postdoc researcher in Aalto University as well, and this is something we've been looking at. I think we have been looking at 34 in total, and I'll show an example, one or two, but this is what we've been deploying in Nokia as well. And the kind of good Finnish examples are Empathic Building, now owned by Haltian. Rapal have a service called WorkSense, and another Finnish company, Steerpath, have a smart office solution as well, I believe being sold by Ateja, the firm. So one really interesting thing about the smart office apps is really, like I said in the Nokia case, thinking how the information is collected. Do you put a desk sensor, like we see on the left here, a desk sensor under every desk? Or can you convince the employees to download an app on their phone and to share their location? And if the app isn't on their phone, then maybe it's on their laptop. And if you can convince people to say, look, it makes the kind of work experience much better. It means that people can really quickly find a space, especially in work environments where it's quite hard to find meeting rooms. Sometimes 1 o'clock is a time when people have lots of meetings. You're trying to find a empty space to have, we have these ad hoc spaces that you can't book. You're trying to find an ad hoc space at 1 o'clock for a Skype meeting that's going to last 30 minutes, and you walk around the building looking for an empty space. So in environments where people say this is a problem and it's acknowledged, and in environments where people say we'd like lots of different working spaces, so we'd like a quiet room, or we'd like a normal office space, like an open office, or we'd like a coffee zone where there's kind of music and it's more like a coffee shop, or they want meeting rooms for team working. So when you provide lots of choice and you really focus on kind of saving people time, people are really interested in kind of having these kind of solutions and downloading on their phone, because it actually solves problems that they've acknowledged in their real life. And then the difference in how the data is collected potentially means that the smartphone or laptop data is more reusable. So if I look here, having information collected with an app and having a user interface for the users allows us to do these boxes that I'm going to show that are colored in orange. And you couldn't do any of these three things, for example, with a desk sensor. You can't have an Office app user interface. You can't have navigation, which directs you to different spaces. And the app as well can be used to kind of give access to smart locks. Another example then is actually if the app is being used to monitor location from a which spaces are being used point of view, when people give feedback with the apps, then it's a really nice way to give accurate location to the feedback. So whether they're saying they're cold, or we have some services in Finland where people are saying I'm stressed today, or I'm angry today, or whatever it is. It's an anonymous kind of almost like an emoticon driven feedback. Then you can really see what teams or what areas are kind of feeling stressed. And also just reporting problems like service requests, that there's a broken lock on a door or a light bulb is gone. When the feedback is given, it's really tightly located to that place. Another example then is things like smart maintenance, that the maintenance guys can use the same infrastructure to find out which things need to be fixed. Other things we've looked at then, you can probably do this with an app or a desk sensor, really looking at kind of cleaning the spaces based on how much they've been used. And in some campuses, the restaurants are really interested, let's say at 9 a.m. every day, okay, how full are the office buildings? We'll decide based on how many people are in the campus, how much food to make. So we'll use that as an indicator of how much food to make and to reduce food waste. Another example then again is probably with the analysis of space efficiency or energy consumption or indoor air quality, probably the desk sensors are good enough for that. But the kind of orange boxes here, for example, are things that you can really only do, let's say, with the app or the laptop solution. So it's really interesting from that perspective that it's probably a cheaper installation, but the data that comes out of it or the ways to use the solution are probably more reusable. Okay, so then one of the things we've also seen in our smart building consultancy in Granlund is really kind of understanding what technologies people want to install in their smart buildings. One real challenge we have is really kind of understanding the hierarchy. Okay, in building one, a customer doesn't have as much budget as they'd like, so they only want a 1 or 2 star smart building, and maybe in a couple of buildings later, they really want a really impressive smart building, and they want a 5-star smart building. And we've really had trouble kind of really understanding which technologies are really mandatory and every building needs to have, and which technologies are kind of nice to have. I think we've found, and we've spoken about this internationally quite a lot, and it's a similar feeling internationally. I think we find that a lot of the smart building technologies, such as turning on the lights with your voice, or certain things like this, are a little bit nice to have, and there's no real technologies that are essential. So we've kind of seen that there's a lot of different competing technologies in the smart building world or in the technology in buildings world. And it's quite difficult for our customers and kind of building owners and investors to really understand what to do. So here's an example of what we've seen. So we have the kind of basics that we understand around BMS and metering and these kind of things. We then have some understanding of, what the different smart layers are, but actually this is kind of made up and it's really difficult to do. Is car charging for electrical vehicles more important than asset tracking or smart washrooms which monitor kind of paper towels and cleaning and these kind of things? It's really hard to say. VOC sensors or noise sensors or voice control, it's really hard to understand which of these things are essential and which are good to have. And then, in some buildings as well, we want customers ask us to connect the building to the kind of city infrastructure as well. And they ask about car share and delivery and kind of smart post solutions where your groceries or your post can be delivered to the office building in a really efficient way. And while we're talking about these kind of smart building things, we always get a discussion about user experience and about the kind of operations phase around kind of predictive maintenance and cyber security and these kind of things. And what we often find is the user experience side is mainly driven by software. The installations are essentially less expensive. And also they're really customer facing or really employee facing in an office building, and they tend to be kind of really popular. So the things that support them seem to be really popular. I think what we've seen is that user experience is often a separate budget than smart building. User experience sometimes is something that is owned by a campus kind of community in office buildings, or even HR or even health and well-being budgets. And we see them as being kind of overlapping. And if you can use the user experience budget and the infrastructure to do that, and let's say it's indoor navigation or something like that, then the sensors and the installation to help make a better user experience actually can reduce the amount of budget needed from the smart building perspective then. So we really see kind of start with the user experience as a really good way to approach these questions. So then from our perspective, we were trying to kind of rank and give understanding of why user experience is really important. You know, the value we feel is created is higher because it's more reusable compared to real smart building core technologies. The visibility to the end users is higher, and this is important. The cost to install them is lower because they're often software dominant. The available budget is higher because they often come from different budgets like HR or health and well-being. Again, it's reusable, and maybe the range of options is lower. There's less competition. There's a lot of competition in the kind of smart buildings software or solutions. Moving then, kind of jumping on next then to kind of looking at digital twins. This is something we've been looking at in Granlund this year, and we've been doing a kind of really deep dive study on it. I think the things that we need to acknowledge at the start is that every kind of stakeholder needs a different user interface, be it a facility manager or an end user or an investor. We've really found the reality that there's a lot more alterations to, you know, retail, office, healthcare, these kind of buildings. The idea that the floors or walls are being knocked down and rooms are being changed is happening all the time. We also acknowledge that the models aren't being updated or the floor plans aren't being updated. And one of the things we've been saying on digital twins, very much like I've said just a moment ago, is that the end user is really important, but difficult to engage in the solutions, difficult to get them to use the solutions. And that's something we really need to focus on. We've kind of talking about hype around digital twins. There has been a lot. Granlund, for example, have kind of done lots of digital twin things in a hospital in Finland, looking at building management systems and accessing the data from them. Indoor conditions in a shopping center in Helsinki. And we also have some augmented reality for FM solutions that we've been developing. And we're really, really proud of these. But we have to acknowledge as well that, you know, the kind of readiness of what we really think of as digital twin solutions is quite far away from being ready. In 2018, Gartner said that digital twins were 5 to 10 years of being ready. And in our research lately this year, we've really seen that the 2018 dot has kind of moved down towards this trough of disillusionment, meaning that the market is kind of annoyed and frustrated that the solutions aren't here yet. So we definitely have to kind of rethink what digital twins mean and what we do for the next 5 to 10 years, or maybe 3 to 8 years, while we're waiting for them to really become productive. So what we've done this year in Granlund is we've been interviewing people in the Finnish market about their expectations of digital twins. The kind of people we've been interviewing have been, you know, owners, investors, renovation teams, meaning kind of architects, construction companies really working on renovation, property or asset managers, facility managers, other service providers providing technology or providing, for example, security or restaurants or reception staff, and kind of occupants and customers of buildings. And we've kind of been collecting their problems and the problems that they would like to see solved in buildings. One kind of thing as well that is a big element is that, you know, big technology enablers, when we think of these things like digital twins or data platforms, they're super complex. And complex meaning difficult to make, expensive to maintain over time. But if we can do it correctly, they have the kind of potential to solve lots of problems. So they really are enablers. So there's this kind of balance between, we would love to have these, they are important, but the acknowledgement as well of they're kind of difficult to make. So from that perspective, we've kind of looked at the different levels of the kind of digital twins to really understand what they can do. One example then that has come up in our interviews with different people is really looking at this very complex digital twin, let's say an as-built building information model. So all of the information from a construction project when the building is opening has been updated and is in one model. From Granlund's perspective, then, we're obviously very interested in kind of talotechnique or mechanical, electrical and plumbing, MEP. digital twins. But then the other things that we've really been talking to stakeholders about is the nice thing of having, like we showed in the Nokia case, an interactive kind of 2D floor plan digital twin. And then another thing that's come up when asking customers about their interest or their needs or their problems that a digital twin could solve is then even something as simple as a Power BI dashboard or some kind of business information dashboard with an interactive 2D plan in it. So when you click a space and you look at the details of that space, it kind of reminds you in which building it's in and what part of the building it's in. And, you know, this is the idea that a digital twin really is just up-to-date geometry or up-to-date, walls and windows and these kind of things, and that it has combined with that, let's say, up-to-date information as well. So the expectation of how complex is a digital twin is we have a quite open-minded approach here. So as I said, with the kind of enablers, we really need to understand that digital twins can create a huge amount of value and solve a lot of problems, but they are a bit of a beast. So they are really complex and kind of difficult to create solutions like that. So one example then is kind of really looking at how do we balance the value they create with the actual complexity of digital twins. And again, complexity means difficult to make, big problems, big costs, and just balancing that and finding the sweet spot between them. So one example then is kind of looking at low value, low complexity being kind of a successful initial product, for example. High value, low complexity being the dream scenario, but probably unrealistic, knowing how complicated building information modeling is, for example. A kind of a failure then is really having high complexity without kind of generating enough value to justify the cost, generating enough return on investment. And maybe the long-term approach then is this high value, high complexity product, let's say. And if we show this same discussion in kind of a different way, I guess one of the questions then is how to get there, how to get the digital twins and how to do it in a kind of lean innovation perspective, like we've been building software and the way startups have been working over the last couple of years. Do we take this kind of iterative approach from, let's say, 2020, 2022, and 2024, and start with something like an interactive 2D floor plan, like a smart office app, and end up towards a simple 2D digital twin and get towards a complex 3D digital twin. There's an opportunity here as well to say, you know what, actually the simple 2D digital twin, maybe the interactive floor plan solves enough of our problems that maybe we never even need to go to a higher level complexity than that. So we have this iterative process. And another thing we've been asking the stakeholders is, do we do it this way, or do we almost take the cable car to the top of the mountain, for example? Do we just believe in the long-term approach immediately, or do we do it iteratively? Actually, we asked some of our customers this recently in an event, and the result was that 180 people voted, and 87% said take the iterative approach and to see what that brings. So we've had a very clear communication from our customers from that perspective. I'm going to kind of show some of this, mention some of this quickly. Our market report on digital twins is out on the 10th of December. I'll put a link in Twitter today if anyone wants to add their email address for the market report when it's out on the 10th of December, and we'll automatically send you a PDF copy. I'll put that link on Twitter for the event. But basically, we're not going to go too deep here because this has been covered quite a lot in some of the hype use cases, and we're trying to talk today about some of the kind of practical routes, the iterative approach to providing digital twins. So some of the things that our interviewees have said is, the complex 3D as-built digital twin, it's really good for renovation projects and, technical due diligence projects and virtual tours and kind of marketing material. It also helps the customers kind of customize their design. Maybe they want to change the color of the paint in a certain place. Maybe they want to change the facade of the building. It really helps to bid for renovation projects. And it kind of helps for design automation as well. Maybe checking the kind of structural design and kind of changing things over time. Similarly, the kind of complex building MEP MEP BIM kind of perspective is about energy and fall detection and predictive maintenance. It's around simulations and maybe VR and AR guidance and design automation. So, redesigning the spaces based on if you change the meeting rooms, maybe design automation can automatically design the new lighting system or the new ventilation system. These are things we're really focused on in Granlund and working on all the time. And we'll have some mentions of these in the report. But one thing that really came out of the report that we hadn't considered so much before is really understanding, where a sweet spot technology could be for digital twins. So at the core here, we have, an interactive 2D floor plan or some kind of simple 3D digital twin, and collecting the use cases or the business cases from the stakeholders kind of has been really interesting. So, we're talking about, it's the user interface for interior designers, or it visualizes people flow for owners, or for example, performance of the building can be put onto a UI for asset managers, or the marketing material for selling and leasing we hear is really important. Facility managers want to visualize equipment and want some kind of user interface to communicate with kind of local maintenance teams. So asking a reception staff or a cleaner who's on site in the building to check something because you have kind of remote maintenance in a control room somewhere. Other things around, user interface for IoT or for smart cleaning or these kind of things. And then again, some of the kind of the smart office app solutions like I showed a moment ago, UIs for space booking and finding and these kind of things. And one really important thing as well is this kind of investor level, almost Power BI understanding, supporting lease management, supporting analysis from the investors who have a very high level of perspective and who may not know the building very well at all, and who really are kind of saying, okay, the lease on this space is expiring soon. Let's kind of have a look at the space. Where is it, etc. And showing it on a map is much more intuitive than just showing it on Excel, for example. Another thing that we're kind of considering in the report then is what will the kind of architecture be of the technology architecture of the digital twins? Could it be that we have, a simple digital twin, which is based on an interactive 2D floor plan? It's used by the Power BI solutions. It's used by the interactive 2D solutions. And then we have another separate, more complicated 3D model, maybe provided by a separate company, maybe with its own revenue model, that's then doing the kind of needs for the as-built complex and the MEP kind of digital twins. Will it kind of start like that and maybe change over time? Or is it likely that we have this kind of central digital twin, this central geometry, or a better word for geometry, I suppose, is digital replica. And it's a central data platform where all of the information is stored there from a data perspective, and from the kind of the replica of the building, the geometry is there, and that all the different use cases or business case from the different customers are kind of extracted from that. It's hard to know where we will go. I think the feedback we've had from the interviewees and from our customers is that we should start simple, and we should start with this kind of iterative approach and really understand the value that is brought by this kind of core concept of let's have the model or the floor plan up to date, and let's embed some real-time information in it. And that's our starting point. That's the core thing, or the minimum viable product that these digital twins need to have. And it allows us to work and to understand what's happening as we wait for the more complex, heavy digital twins to kind of become profitable, and maybe for some of the data exchanges and standards to emerge a bit better. So as I said, the report is going to be released on the 10th of December. We're really looking at kind of value created, what could the initial solutions be, what is the revenue model, if we expect the customer to pay, the building owner to pay, what are they getting in return, and really looking at the kind of architecture. And as I said, I'll put a tweet at Ken Dooley. So if anybody wants to get a copy of the report when it's released in December, there's a link there where you can put your details, and it'll automatically be sent to you then. Okay, thanks for everyone for the invitation to speak. And if there's any extra information, you can contact me on the details below. Thank you.
Thank you, Ken. Ja nüüd siis on meil aeg ja võimalus esitada Kenile mõned küsimused. Ken, are you still there?
I'm still here, yes.
Yes, very good. So, listening your presentation and what you're describing is a little bit that we as a users, we would like to have this kind of like Uber or Bolt or Volt kind of application to interact with the building and to interact with the software that is running the building. So, but from the other hand, you need to have a very good data. You need to collect and organize the information. So my question to you is, will Google come to building management business? Because Google is gathering and organizing the information in the whole world.
Yeah, I think the thing is that there's so much to do. Maybe Google could be the data platform. Maybe they could be this kind of place where the data is housed, and then there's some ontologies or semantics put on top of it, so I can find the data I need. So if you save CO2 as CO2 and I save it as carbon dioxide or whatever it is, that we can find all the data. But I think all the things that we mentioned around the kind of smart building hardware and around the user experience solutions, and even around the kind of geometries, updating the models and updating the floor plans, I guess there's a lot of different elements there. And I think Google would only take the most lucrative kind of core element of it, which might be this kind of database or data platform. But there's lots of work for other companies to do.
Okay, thank you. So how many people out of this 3,000 used this app in Nokia office building when you tested it?
Yeah, everyone is using it now. And it was tested actually in a different country, and it was rolled out to Nokia, not with people really testing it as such, but with a kind of working group giving us advice on what it should be, but it was really tested in a different country.
Okay, so what could be the ecological footprint of this technology? So how it changes?
Actually, when you say ecological footprint, you kind of mean from a sustainability point of view and from a kind of climate change point of view? Is that what you mean?
Okay, but if you're collecting all this data and exchanging all this data, so what about security? So how do you solve this?
I think one of the new things now from a machine learning point of view is things like edge technologies. So not only is it saving the amount of data that we would collect, but it's also allowing that the device is doing some work on itself. So when I say edge technologies, it could be a temperature sensor. And instead of the temperature sensor saying this room is 21 degrees or 22 degrees or whatever it is, and reporting that every 10 or 15 or 30 minutes, edge technology would have some intelligence on the sensor, and it would only report when the temperature changes. It might be 5 minutes, it might be 2 hours. So actually the device isn't just a sensor, but there's actually some processing on it. So then that saves unnecessary reporting of the situation in the building, but it also means that something like a security camera wouldn't have to, if it was using facial recognition or if it was doing something like that, it actually could do the processing on itself, and it wouldn't be connecting to the cloud. It might have your face stored on it, and instead of actually saying you were in the building, it might just give your ID number or something like that. So I think one of the really interesting things with reducing some of the amount of data and in some of the kind of protection things is really interesting things coming from edge technologies, edge AI.
Okay. And the last question too is, when the smartphones came to our lives, then I personally felt that it made me a little bit more a little bit more like stupider, not so smart anymore. So will the smart buildings make us also like dumber?
Yeah, it's a really good question. I think now that we have this capability, now that we have these enablers, I think they kind of change. So I think, like I was trying to say, I think they mightn't be dumber, they just might be easier to use. So instead of me having to go on a course to learn how to use the new software that's installed in my building, maybe if it's really smart, instead of it taking me 1 day to learn, maybe I can learn it in 1 hour. Or instead of it doing lots of things for me, maybe it offers personalization or offers more choice. So like we've talked about in office buildings, people don't want an office building that's 10 times better. Maybe they want kind of choice of a phone booth to make a call in, or different sized meeting rooms, or a really quiet area to work in, or a vibrant area like a coffee zone in the afternoon just to chat to people and write emails. So I don't think they're going to make us stupid. I think they'll really just offer us choice and maybe make us safer and maybe be easier to use and more intuitive. That's the hope and that's the expectation.
So it's not about the technology, it's about us and how we use the technology. Thank you, Ken. It was nice to meet you. Great. And have a nice day, and hopefully all the nice things that you described will be a reality one day. So thank you. Bye-bye.
Thanks. And if anybody wants access to the... Bye.